So, dependent events depend on something happening to the first event. So, if you were to go and, like, you're at an ice cream shop, because we just talked about ice cream for one of our conferences. So, if you're at an ice cream shop and there's a little bit of peanut butter and chocolate left in the bowl at the ice cream shop, and the person in front of you gets the rest of that peanut butter and chocolate, there's not any left for you, or there's less left for you. So that is a dependent event. What someone else does, or what happens before the event that you want to happen, or before a different something happens over here, it butterflies affect what happens over here. So we are looking at dependent probability, slide number 2. So it says there are 9 girls and 11 boys in a class, and 2 students will be chosen one after another. So because if someone gets chosen, that means they're not they're not a possibility anymore, right? So there's one less student. So it says there are 9 girls and 11 boys. So in total, there are 20 kids in the class. Now, of those 20, it says, what's the probability that both are boys? So there are 11 boys in the class. So 11 out of 20 possible options first. Then it says, both are boys. So this is my first choice. Now I'm making a second choice. Now because I've already chosen one student in the class, this total can't be 20. I take one away because it can't be 20 anymore. So I still have 19 kids in the class to choose from. Now what if the kid I chose in this first one was in fact a boy? So there's not going to be 11 boys anymore. There's going to be a possibility of 10 boys. So this is dependent probability. So then we're going to go ahead and multiply those straight across. So 110, and then 19 times 20 is, I have no idea. So 19 times 20 is 380. Now you're not going to see that answer because this can be simplified. So I can take both zeros off, and that's 11 over 38. So then number 2, it says in a box of 11 batteries, 2 are defective. If 2 batteries are chosen, what is the probability that both are defective? So we have 11 batteries in this box. I don't know why there's 11. There should be 12. There's 11. So there's 11 batteries in the box, 2 of which are defective. Now, if I choose one battery, there's only 10 batteries left in the box. If one of the batteries I've chosen are defective, how many batteries are still possibly defective? Well, it's 1 battery left. So 2 times 1 is 2. 11 times 10 is 110. Right? Yeah. Since these are both even, I'm going to go ahead and divide the top and the bottom by 2. So I get 1 and 10 divided by 2, 55. So 1 over 55. Okay. So then, number 3, from a standard deck of cards, what is the probability of choosing 2 aces? So a standard deck of cards is 52. Have you ever heard the 52 card pickup? No? So, the 52 card pickup is a standard deck of cards has 52 cards. You pick up the cards and you tell your friend, hey, have you ever heard of 52 card pickup? Want to play? Great. And then you flick all the cards so they all fall on the floor, and then you're like, 52 card pickup, you go. And they pick up all the cards. Anyway, so there are 52 cards in a deck of cards. So it says, what's the probability of drawing 2 aces? Well, there are 4 aces. The ace of spades, clubs, hearts, and diamonds. So 4 different possible aces in a deck of cards. So if I choose a card out of my deck of 52, I don't have 52 anymore. I have 51 cards left in the deck. If I choose an ace from this set of 4, I no longer have 4 aces to choose from. I have 3 aces to choose from. So now I have 4 over 52 and 3 over 51 because one of the cards got picked out. So now 4 times 3 is 12. And 52 times 51 is 2,652. Now, they are both even, 2 and 2. So I'm going to divide the top and the bottom by 2. So I have 1,326. And I have 6. They're still both even, so I have to divide the top and the bottom by 2. Now, if you knew they were a bigger number, great. I'm doing it step by step. So 6 divided by 2 is 3. And 1,326 divided by 2 is 663. Which is not quite an answer yet. So they both have a 3, so now I'm going to divide by 3. So I have 221 over 1, and that is an answer. So that's for your card pickup. My last problem, it says 4 out of 10 students use the bus to get to school. If 2 students are surveyed, what is the probability that they do not ride the bus? So 4 out of 10 do ride the bus, which means 6 out of 10 do not ride the bus. So I have 6 out of 10 students that do not ride the bus for my first possible probability. So it says what probability do not ride the bus if I pick 2 students? So I have to have 2 sets. So this set and another set. So if there were 10 students at first, and I take one away to interview them, I don't have 10 students anymore. I have 9. So 6 gets taken away because I don't have 10 or 6 students anymore. So I have 5. Now, there are no fractions with 6 over 10 as a number. There are fractions on your assignment with 9 over 10, which means this one is simplified, 3/5. So if we were to simplify this one's 3/5, we can't simplify this one. So 5 over 9. So the same thing applies to the 52 card pickup, it looks like. So look for the second fraction. So 3 times 5 is 15. 5 times 9 is 45? Yes. So these are both 5s, so I can divide by a 5. 15 divided by 5 is 3. 45 divided by 5 is 9. You could also cross multiply, and we'd have 3 over 9, which can simplify to 1/3. Okay, so there is dependent probability, and the big thing is that you take one of the options away in your second thing, in your second event. If you have questions, please ask.